So let's look at our previous lesson. So with our previous lessons, we learned how to find the gradient when 2 points are given. And then we said gradient, which is m equal change in y over change in x. And then we also learned how to find the angle of a straight line when the equation is given. That is, we equate the gradient to tan theta, giving us tan theta equal to m. Now to today's lesson objective. By the end of the lesson, the student will be able to find the equation of the straight line when gradient and a point is given. Equation of a straight line when a gradient and a point is given. So if A, which is x1 and y1, is a point on the xy plane, and m is the gradient of a line, where p, x and y is a variable point on the line. Therefore, the rule for finding the equation of the line is going to be m equal y minus y1 over x minus x1, where we know how to find our gradient. And then we know gradient is change in y over change in x. But with this, a point is given, and that is why the point is x1 and y1. So the other point, which is the x and then the y, becomes a variable point, which means that we cannot substitute values for them. And if you have it in this form, you can also express it in a linear form. So if you don't want to use it in this form, you can also express it in a linear form. So the formula for finding the equation of the line when the gradient and a point is given. If you want, or if you prefer to use the linear one, it means that we are going to multiply through by the denominator. So when you multiply through by the denominator, this is our final rule for finding the equation of the line when a gradient and a point is given. That is y minus y1 equal m into bracket x minus x1, where x and y are variable point, and then x1 and y1 are the point on the xy plane. Okay. So let's take our first example. So a straight line has a gradient 3 on 2 and passes through the point 1, negative 3. Find the equation of the line. So we start. So before we start, you have to write out the little information in the question, and this we term as data. So from the question, we're giving gradient, so we write our gradient, and then we're also giving the point, which is x1, y1, which is 1 and negative 3. So since my gradient is in a fraction form, I'm going to use my first equation, which is m equal y minus y1 over x minus x1. So now I know my gradient to be 3 on 2. I know my point to be 1, negative 3. So I know gradient to be m. So I'm going to replace m by 3 on 2. I know x1 to be 1. And then I also know y1 to be negative 3. So in replacing it, this is what you are going to get. So from here, we are going to do the crossing. So 3 is going to multiply the denominator. And then 2 is also going to multiply 2, which is a denominator on the left hand, is going to multiply the numerator. And so when you multiply, this is what you are going to get. So this is going to give you a linear form. So you expand. So we have 2y plus 6 equal 3x minus 3. So from here, you are going to arrange your final answer in a standard form or in the general equation form. Either you are leaving it in the standard equation form or you are leaving it in the slope equation form. So I prefer to leave it in the standard equation form. So we have ax plus by plus c equals 0. So it means that the right hand side must always be 0. whether you want it to be at the left or the right, one side must be 0, starting with x. So we have 3x minus 2y minus 9 equals 0. So this is the final results for example 1. Now let's try example 2. So with example 2, we have the equation of the line whose gradient is 3, passing through the points 0 and 1. So now we are going to write out our data. So we have gradient to be 3, and then we also have our point, which is x1, y1 to be 0 and 1. So with this one, I'm going to use the second equation, or the second rule, or the second formula. The reason why I'm going to use the second formula is because my gradient is a whole number, not a fraction, to make things simple. So I have y minus y1 equal m into bracket x minus x1. So either you are using this second rule for all your questions, or you are using the first rule for all your questions, or you are mixing them. It is up to you. So I know y1, I know x1, I know m. So I have y minus 1. Then I know my m, which is gradient to be 3. Then into bracket x minus 0. So I'm going to get y minus 1 equal 3x. So I'm going to arrange it in the general equation form. So it means I have to begin with x, then move to y, then a constant before my equal to 0. So I'm going to get 3x minus y plus 1. That is moving y minus 1 to the other side where 3x is, so that we make one side equal 0. So this is my answer for example 2. So I have a try work for you guys to do. Find the equation of the line with the given gradient and passing through the given point. So I have gradient followed by the point. So the gradient, comma, the point. So with our next lesson, we are going to find the equation still under the equation of the line. Finding the equation when 2 points are given. When 2 points are given.